Welcome to Homework Help Class, Pre-Calculus students. This is the assignment here that you should be on, so if this is not the one that you were on, then you are not watching the correct video. Okay, let's get started here. Page 7, numbers 1 through 10. Let's start with those first. Alright, number 1. There we go. Number 1 says for you to find which numbers are the whole numbers. Now, based on the definition that I gave you, whole numbers start at the number 0 and they proceed to the right. So 0, 1, 2, etc. The negative numbers do not count. So this is not a whole number, this is not, 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 no, 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 yes, no, 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 no. So the whole numbers in this list of numbers are 0 and 9. Remember my philosophy, I go fast on videos. You can always pause it and go back if you need to, okay? The reason I do that is you cannot speed up the video, but you can always pause it. So I go fast and we go that route. So 0 and 9 are your two whole numbers. Now let's take a look at number 2. Alright, problem number 2 says which ones are the integers. Now, if you remember the definition I gave you, integers are negative numbers. Now, integers, if you look at your definition, would be negative numbers like -3, -2, -1, and then 0, and then 1, 2, 3. A little sloppy there, excuse me, then continuing on. So, this would be an integer. No, 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 no. This would be no, 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 no. This would be, and the rest are not. So integers, out of this list of numbers, your integers are -12, 0, and 9. Alright, so those are your integers. Alright, let's continue on. Let's take a look at number 3. Number 3 asks which numbers are the irrational numbers. Now remember, be careful, irrational numbers are non-repeating, they don't repeat, and non-terminating. That means they don't terminate. They continue on and on and on without repeating. For example, a number like 2.6 9, 5, 3, 4, on and on and on. If it kept going on with more numbers that never stopped, that means it's non-terminating, it continues on, and it's non-repeating. There's no pattern. If we had a number like 2.636363, well, it's repeating. You can see that. So it would not be irrational. Irrational numbers do not terminate and they do not repeat. Alright, so with that in mind, let's see if we can't go up here and figure out the irrational numbers. Okay, this is obviously just a whole number or an integer. If you type square root of 7 into your calculator, you would get a number that goes on and it does not repeat. So this is an irrational number. This repeats, 5.33333. You're looking for non-repeating. They don't repeat and they don't terminate. This repeats. If you typed in 7 divided by 3, you would get 2.333333. Now you see cubed root of 8 and you're like, oh, it's got to be irrational. Hold it. If you typed in the cubed root of 8 into your calculator, you know what you would get? 2. Because 2 times 2 times 2 equals 8. So no, that is not irrational. It totally terminates. The cubed root of 8 is 2. Alright. No. Now be careful on this one. I don't see any bars. The numbers don't continue on and on and on. So I'm not sure what the back of the book said on this one. I would say this is, we would not use this. That's not irrational because it stopped. Now if they would have put ... after the number, and actually in the book they did, didn't they? So I apologize. They did put ... Okay. So then this would be irrational. It means it continues on and on, but there's no pattern. There's no repeating anywhere. Negative square root of 14, that would definitely be irrational. If you type that in, you'll get a decimal that goes on and it does not repeat. Same thing with this. If you type that into your calculator. This is not irrational. No, this isn't. This is 4.66666. This is not irrational. The square root of 25 is just 5. The cube root of 4, that's irrational. And this is not. So we have 1, 2, 3, 4, 5 irrational numbers. All right, let's take a look at the next problem in your book, which is number 4. Number 4. Okay, which ones are the natural numbers? Based on the definition that I gave you, the natural numbers are starting at 1 and moving to the right. So 1, 2, 3, etc. Note the 0 would not be a natural number. So that's not a natural number. That's a negative number. No, 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 no. I only see one. Well, I got to be careful here. I really got to be careful, and I apologize. The cube root of 8 would be 2. And so I would definitely count that as a natural number. And the square root of 25 would be 5, and that's a natural number also. So I would say those 3, 1, 2, 3, are your natural numbers. Okay? All right, let's continue on. Take a look at number 5. All right, number 5 says, which are the rational numbers? They're rational. Well, that means they are integers, or they terminate, or they repeat. So we're looking for numbers that are integers, or they do repeat, or they do terminate. They come to an end. Well, this is an integer. This one repeats. This one repeats. This is an integer. Remember, it's 2. This is an integer. Now remember, this one has dot, 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 so it does not terminate. It doesn't repeat, so that's no good. A rational number is either an integer, or it repeats, or it terminates. This would not repeat or terminate. This one would go on and on without repeating. Now this one terminates. Negative 1.96. This is an integer. This one repeats. 4.66666. This is 5. Now this one here, this would go on and on without repeating. So that's not going to be irrational, or rational, excuse me. And then 5 divided by 7, now please watch this. This one does repeat. It's 0.714285. And then I'm running out of room. I apologize. 0.714285. 714285, and on it goes. So this whole group right here keeps repeating. So this is a rational number because it's repeating. That was a tough one. You might not have caught that, but it is repeating. So it is a rational number. All right, let's take a look at number 6. Number 6 in the book says, which ones are the real numbers? Now remember, real numbers are every number that's not imaginary, and we're not dealing with imaginary numbers yet. Okay, none of these are imaginary. So when number 6 says list out all the real numbers, well, it would be all of them. Okay, so all of the numbers are real numbers. I gave you that definition. I think it was the first one I gave you. All right, let's take a look at number 7. Back to number 6 again. Remember, all the numbers in our number system are real numbers, except for imaginary numbers. And we've not gotten into those yet. Okay, number 7, which are rational numbers but not integers. Okay, now, if you'll allow me, please, let's go back to number 5. Here are the rational numbers. We already listed them out. Now, number 7 says, which are rational numbers but not integers. Well, this is an integer, so I don't want that one. This is an integer, so I don't want that one. This is an integer, so I don't want that one. This is, cross it off. Square root of 25 is an integer because it's 5. Cross that off. So, the numbers I would have that are rational, but they're not integers, would be these numbers I have circled. So 5.3 and negative 7/3. So 5.3, negative 7/3, negative 1.96, 4 2/3, and 5/7. 5/7. Those are your rational numbers that are not integers. Okay, let's continue on and take a look at number 8. Number 8. All right, number 8 says which ones are integers but not whole numbers. All right, now let's circle all of our integers real quick if we could. Hopefully I'm not missing any. I think this is it. Integers. Okay, these are your 5 integers. Now, number 8 says which ones are integers but not whole numbers. Not whole numbers. Well, whole numbers start at the number 0 and they go to the right. So this would not be, let's see, I apologize, hold on one second. Which ones are integers but not whole numbers? Sorry about that, I had to pause real quick there. Okay, these are your integers, but it says in number 8, not whole numbers. Well, whole numbers start with the number 0, and this is a whole number, that's 2. This is a whole number, this is a whole number, this is 5, so it's a whole number. So the only one of these integers that's not a whole number is -12. That's the only one. All right, let's continue on and take a look at number 9. Number 9. All right, number 9 says which are integers but not natural. So let's once again quickly circle our integers here. And now the question says they are not natural numbers. Not natural numbers. Well, natural numbers start at 1 and go to the right. Okay? So this would be a natural number, it's 9. This would be a natural number, that's 2. This would be a natural number, that's 5. So which one of these numbers are integers but not natural numbers? Well, -12 and 0 are both integers, but they're not natural numbers. And that would be number 9. Okay, let's continue on for our last problem before we turn the pages and go on to page number 14, I believe it is. Before we do that, let's quickly take a look at our last problem, which is number 10. Number 10 says, which ones are real numbers but not integers? Now remember, all of them are real numbers. So which one of these numbers are real numbers? All of them, but not integers. So I've got to cross off my integers. Remember what integers are? It's like dot, dot, dot. -3, -2, continuing on all the way up to 0, 1, 2, etc., and then dot, dot, dot. So I'm going to cross off my integers. This is an integer here because it equals 2. This is an integer, it's 0. This is, and this is. So every number that I did not cross off is a real number that is not an integer. There you go. I hope that makes sense. Okay, let's continue on now in your assignment. Next, we're supposed to go to page 14 and do some scientific notation problems. I think you'll find these pretty easy. We're supposed to do numbers 51 through 67 odd. 51 through 67 odd. All right, let's start off with number 51. I think you'll find these problems pretty easy. Hopefully you found the whole lesson easy. All right, 405,000. I'd like you to write that in scientific notation. Now, remember, you're going to want to move the when you don't see a decimal, it's always at the end to the right. And you're going to move that decimal all the way until you have one digit, right here, to the left of the decimal. So here's where you want to move the decimal to. So with that in mind, let's get going. We're going to move it 1, 2, 3, 4, 5. So I moved it 5 places. So scientific notation would be 4.05, and then cross off all the other zeros on the end, times 10 to the 5th place. All right, pretty simple. All right, let's take a look now at number 53. Now, hopefully you saw in the homework assignment it did say odd. It said 51 to 67 odd. All right, let's take a look at number 53. I'm trying to count the zeros. It looks like it's 1, 2, 3, 4, 5, 6. 6 zeros. So point, and then 1, 2, 3, 4, 5, 6, and then 3, 9. Okay, we're going to write this in scientific notation. Now, a couple quick thoughts. First of all, notice it's not a big number. It's a really small number, like 0.00000. So we are going to move the decimal this direction. Number two, remember these zeros, when I say move the decimal so that there's one digit to the left, we're not counting the zeros. A lot of students want to go here, and that's not right. And a lot of students want to go all the way to the end. If you go to the end, then you have 2 decimal places or 2 digits to the left, and that's not good. So you want to stop right here so that you have 1 digit to the left of the decimal. So that's where we're going to move our decimal to. So here we go. We're going to move it 1, 2, 3, 4, 5, 6, 7 places. So 3.9 times 10, now it would be a -7 because you're dealing with a really small number where the decimal's over here to the left and you're moving it this direction. So there we go. Moving on to number 54, or excuse me, number 55. All right, looks like we have 234 billion, 600 million. And if you don't see the decimal anywhere, we know it's here on the end. And we know we're going to move it all the way to right here. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to start going a little faster now. We should have this down, 2.34 times 10 to the 11th power. Okay, let's move on to number 57. Number 57. 0.00104. Okay, let's write this in scientific notation. Remember, you're going to want to move the decimal to right here so that you have 1 digit, this 1, to the left of the decimal. So let's move it 1, 2, 3 places. 1.04 times 10 to the -3. Now notice it would be a negative number because we're moving the decimal from the left to the right. It's a real small number. And so there's your answer. All right. Excuse me. That's number 57. Number 57. All right, number 59. I did not feel like number 59 was worded very well. All they want you to do there is just change, maybe you understood it, they just want you to change that number to scientific notation. So 0.000016. We're going to obviously move the decimal to right here. So that would be 1, 2, 3, 4, 5 places. So 1.6 times 10 to the -5. All right, so there we go. Let's continue on now to number 61. Number 61. All right, in the book we have 8.3 times 10 to the -5. Now, notice the exponent. They want us to write these numbers in standard notation, regular notation. Notice we have a -5, so we're not going to move the decimal this way. That would give us a really big number. We're going to move the decimal this way 5 places. So I start off with 8.3, and now watch carefully as I move the decimal. I start here and I go 1, and then 4 more places. So 2, 3, 4, 5. So I'm going to have to insert 4 zeros. Now a lot of students see that 5 and they think automatically it's 5 zeros, and that is not correct. It's 0.00083. All right? All right, there we go. And I'm not sure what's happening here, students. I apologize. I think I hit a wrong button. Hold on a second. Okay, let's move on. Take a look at number 63. All right, number 63 looks like this. 2.07 times 10 to the positive 7 power. Now that means I'm going to move the decimal to the right. I'm going to have a really large number, so 2.07. And let's move it 7 places. So 1, 2, and now 5 more. So 3, 4, 5, 6, 7. So I'm inserting 5 zeros. And now the decimal is way over here on the end. So my answer is 20,700,000. 20,700,000. Let's take a look at number 65 and then 67, and we're finished. So number 65 would be 3.496 times 10 to the 10th power. So we're going to very quickly move the decimal 10 places. It is a positive exponent, so we're going to move it to the right. We're going to get a really large number. So 1, 2, 3, and then 7 more places. 4, 5, 6, 7, 8, 9, 10. So it looks like we're going to have to insert 7 zeros. So your final answer would be, let me write this down quickly here, 1, 2, 3, 4, 5, 6, 7. 34,960,000,000. And now we're looking at number 67. Number 67, 5.41 times 10 to the negative 8. Now notice it is a negative 8, so we're going to have to move the decimal to the left to get a really small number. Okay, negative exponents means you had a really small number. A positive exponent means you move to the right for a really large number. So here we go. Let's move it 8 places. 1, and now 7 more. 2, 3, 4, 5, 6, 7, 8. So my decimal is here, and it looks like I'm adding 7 zeros. I know my handwriting's not the best, but hopefully you can see that okay. So 1, 2, 3, 4, 5, 6, 7, and then 5, 4, 1. I hope this homework video has been helpful. If you have any questions, don't hesitate to contact me.